All right, so here we want to look at spring 2025. Thank you for subscribing. Now let's start with question 1. Now we want to find the derivative of the following functions. Now the first function that we have is here. We have x squared and then the sine inverse of x. So if you have already watched for 2024, I gave you some tips at the end of the video how to differentiate trig functions, trig inverse functions, right? So now let's see what we are going to do here. Now the first thing that we need to keep in mind here is, now here we are going to use the product rule. That's very important here. We are going to use the product rule. So what I'm going to do is I'm going to say, okay, this is equal to AB, and then I'm going to choose my A to be equal to x squared, and I'm going to choose my B to be sine inverse of x. So now I ask myself, what is A prime? You cannot see that is 2x. But what is B prime? So if you stayed up to the end of the video, the tips that I gave, now when I differentiate sine inverse, we are going to have 1 divided by square root of 1 minus x squared. So this is what we are going to get from this. So it means that f prime, since we are using the product rule, this is a b prime plus a prime b. So let's do substitution. A b prime. So we are going to have this one to be x squared divided by square root of 1 minus x squared plus a prime b. So a prime b here is going to give us 2x sine inverse of x. Very simple, right? So now let's put this one here. X squared divided by square root of 1 minus x squared plus 2x sine inverse of x. So very simple. So I think the only thing that we need to learn from here is we need to remember the product rule, and we need to also remember how to differentiate the sine inverse. Make sure you know all of them. If you have not watched the previous video, please make sure you just go and watch, because it's very useful. Now let's look at this one too. Again, the same trick that I gave in the previous video for tan inverse. So now let me write it here again for you. So we said for us to differentiate tan inverse of u, this is equal to 1 divided by, it's either 1 plus u squared or u squared plus 1. Any of them works. Anyhow that you want to write is okay. So I'm going to use 1 plus u squared times u prime. So now when I compare this to this is tan inverse, this is tan inverse. So the one in the parentheses is the same. So I can see that now my u is equal to cos of x. I need u prime. So what is u prime? This is minus sine of x. So now what is f prime of x? Now I'm going to use this, because when I differentiate sine inverse, this is what I have. So I'm going to have 1 divided by 1 plus cos of x all squared, which is my u, right? Which is squared here, times u prime. U prime here is minus sine of x. So now if I want to write it in this box, I can write it as minus sine x divided by 1 plus. Now we can just write cos all squared as this. So I can write this one as cos squared of x. So that one too is very simple and straightforward from there. Now find all critical points. So let's go through the process again. Our critical point makes sure that f prime is equal to 0. So first we need f prime of x. Use the power rule. We have 3x squared minus 12x. So that's what we are going to get from there. Now we can see that we can factor 3x out, and it will be left with x minus 4. So we see that for us to get f prime to be 0, 1, x should be 0 and x should be 4. So this will be our critical points. Now we are looking for absolute maximum and minimum, and as usual, if you stay for the last video, you see that I gave you tips that this we need the x and we need the original function, which is f of x. And we need to start by writing our endpoint, which is 1, minus 1 and 1. And then anything in between here should be the critical point. Now 0 is indeed between minus 1 and 1, but 4 is not in the domain. So it means that we are not going to use it. So now we need f of minus 1, f of 0, and f of 1. What is f of x? F of x is x to the power 3 minus 6x squared plus 1. Yes. So now let's do that. Plug in minus 1 here. X to the power 3 minus 1 is going to be minus 1 minus 6, because minus 1 squared is 1 plus 1, and this is minus 6. Let's plug in 0, and this one will be 1 because everything here goes to 0. Plug in 1 and you're going to have 1 minus 6 plus 1, and this is going to be minus 4. So what should be the minimum? So minimum is going to happen here, and then the max will be here. Good. So we can see that the max value is equal to 1, and then minimum value is equal to minus 6. Right? Sometimes we can write it in a coordinate form, so we can have this one to be 0, 1, and this one will be minus 1 and 6. Yeah, it's also correct. Now let's look at question 3. So question 3, we want to use a sign chart to find increasing and decreasing. So for us to draw the sign chart, we need f prime. Fortunate for us, f prime is here. And then after f prime, we need the critical point. So now let's pick the critical point. A critical point is when f prime is equal to 0. So it means that minus 16 x plus 3 divided by x minus 1 to the power third should be 0. Now this is what we need to think about. Critical point are the point that makes the function 0 or undefined. It means that here we need to think twice. We need to think about the values that will make the function 0, because this is rational. So I'll pick just the top and set it to 0. And think about the value of x that will make this one 0. And I see that when x is equal to minus 3. Then I'll pick the denominator 2 and set it to 0. And think of value of x that will make this one 0. And I see that x is equal to minus 1. So now the critical point is minus 3. Oops, this one should be 1 rather. So the critical point is minus 3 and 1. So now let's use a sign chart. I have my minus 3 here. I have my 1 here. Now here we are using the f prime. So I'll put my f prime here, put negative 4 in. F prime here, put my 0 here. And then f prime here, I can put 2 here. So now let's try and figure out how we are going to get the values. Okay, let me shift this one up small. Now we are using f prime. So now let's go. When I plug in minus 4 here, this is going to be minus 16. When I plug in minus 4 here, this is going to be minus. I'm just interested in that. When I plug in minus 4 here, this one will be minus 5. And minus 5, when because of this one is odd, it's come with minus. It's going to come with minus again. So this one will be minus. So minus will cancel minus, and still we have minus. So this is minus, and this is decreasing. Now let's go for 0. So minus 16, when I plug in 0 on the top there, I'm going to have positive, because 0 plus 3 is positive. And then when I plug in 0 here, the denominator will be just minus 1 to the power 3, which is also minus. So I'm going to have minus divided by minus, which is positive. This is positive, this one was minus. So this is positive, and this is increasing. And then the last one is when I have 2, plug in 2, the top will be positive. Plug in 2 at the denominator, 2 is going to be positive. So indeed, this is going to be minus. So we are going to have another minus, which is also decreasing. So now let's write the intervals. Let's write the intervals. So increasing interval, I have increasing interval. So what you can do is, after watching this video, you can download the sheet and then solve it on your own without checking. If you get stuck, and then just come and watch the video again. So increasing interval is -3 and 1, and the decreasing interval is at -infinity to -3 and from 1 to positive infinity. Good. So this is what you are going to get from this. Now B, use a sign chart to find the interval where f is concave up, down. Now, so if you remember, we said concave up and down, we need to use a second derivative. And for us to use a second derivative, we need to find the values of x that will make sure that f prime prime is equal to 0. So now let's do that. Let me write f prime prime here again. F prime prime of x is equal to 32 x plus 5 divided by x minus 1 to the power 4th. So we want to set this one to 0. So we are going to have 32x plus 5 x minus 1. So here too, we want to look for the values that will make this one 0 and undefined. So I will just pick the 32x plus 5 and set it to 0. And I can see that when x is -5, it gets to 0. And also x minus 1 to the power 5 is equal to 0. And I see that when x is equal to 1, this one gets to 0. So now we can have -5 and 1 on the sign chart. So let's see what we can do here. Now here, remember, we are using the f prime prime. So plug in -6, here plug in 0, and here we can plug in, let me see, okay, 2 is a critical point, so we don't want to use it, so we can pick 3. Good. Now let's try and figure out. Plug in -6 here. So -6 is going to be 32. -6 will make the top minus. And then -6 here, because this one is even, which is 4, the denominator will be always positive. So this is going to be minus. And when it is minus, we have concave down. Let's plug in 0. 32, 0 on the up is going to give us positive. And then, as we said, the denominator is always positive because of the to the power 4th. So this is going to be positive. And when it is positive, we have concave up. And then let's check when it is 3. So when it is 3, we have 32 positive, and this one too positive, which is positive. So another positive, and we have concave up. So now question is asking us to look for the intervals, right? Good. So here, let's look at concave up interval. Concave up interval should be -5 to 1. Let's talk about concave down. Concave down interval is going to be from -infinity to -5, and then from 1. Oh, okay. I think concave up should be rather 2. Okay. So concave down is just 1, which is -infinity to this, and this one rather should be from 1 to positive infinity 2 as well. Good. So that will be the concave up. Now let's look at question 6, question 4, which is optimization question. So two non-negative values such that when we add it, we get this. So we have 2x plus y, which is equal to 12. So I love this by making y the subject. So when you subtract -2x on both sides, we have this. Now we want to minimize We want to maximize this function here, x squared y. Now, since we've made y the subject here, we can just plug it in here. So we are going to have x squared times 12 minus 2x. And we can say that, okay, this function is equal to f of x. And when I multiply it through, I'm going to have 12x squared minus 2x to the power 3. So we need the quantity that we are going to optimize. That is the function in terms of x, which is true here. And we want to also give the domain. So the domain here, since this one is this, x should be greater than 0, y should be greater than or equal to 0. So y, we replace y by this because it's equal to this. So we are going to have 12 minus 2x is greater than or equal to 0. Add 2x on both sides and have this. Let's divide through by 2 and we are going to have 6 greater than or equal to x, and this is the same as x being less than or this. So the domain should be 0 and 6 here. That should be the domain from here. Now let's look at B. So we want to use calculus to find the value of x. Let's make sure that this is being maximum. And we should also verify that value of. So now let's do it. Now for us to do that, it means that we need the f prime of x. So let's do that. F prime of x is equal to 24x minus 6x squared. So now what are we going to do here? I can factor 6 out here, and this is going to be, is it 4? 6 times 4 is 24 minus x. So I can see clear here that when x is equal to 0, the function will be 0. And then when x is equal to 4, the function 2 will be 0. So this is two critical values. But now we need to verify which one is going to make sure that this function is maximum or minimum, because we need to verify so that we can choose one here. So the best way to do this is, let's put this one into our sign chart, 0, 4, and let's see where the minimum is going to happen, right? So let me pick any value before this. So let me pick something like f prime of minus 1. Let me pick f of, but even though minus 1 is out of the domain, but we will talk about that one. Let me pick 2 here, and let me pick 5 here. Remember, we are using f prime. Plug in minus 1 inside this. Minus 1 here will be minus. This one will be minus. And minus 1 here will also be minus. So it's going to be times minus. So this is going to be positive, and this one will be increasing. Now let's look at 2. Plug in 2. 2 here will be positive. 2 here will be positive. So this is going to be positive plus positive, which is positive, and this will be also increasing. And then when you look at 4, when you plug in 5 here is going to make this one minus and positive. So this is positive minus, and this is going to be minus, which will be decreasing. So we can see that the function is increasing, also increasing here, and decreasing here. So the sign is no change, it's just changing at this. So this one is like maximum. So now we can choose our x to be equal to 4. So this is the x that we want to choose here, to choose our value. But now question also saying that we should verify the value again. So this one now, this one we can use the table, right? Now we need to make sure that we have our domain 0 and 6, and anything in between should be the critical point. So critical point is 0 and 4, which is in between. So 0 is already there, so we pick the 4 here. F of 0, f of 4, and f of 6. Now f of x is equal to 12x squared minus 2x cubed. So plug in 0 and everything goes to 0. So this is equal to 0. Now plug in 4. 4 squared is 16, right? And then 16 times 12 is a whole lot. So we are going to have 16 times 12 minus 4 to the power 3 is, I think, 84. So 2 times 84. Yeah. And I don't know how this is going to be, but this one should be given as 64. Plug in 6. 6 squared is 36. So 12 times 36 minus 6 to the power 3 is, that's a lot. 6 to the power 3. I think this one too is going to give us 0. I think the endpoint should be given as 0. So we can see that indeed the maximum is still at this here, right? So we can see that maximum value is x is equal to 64, or is equal to 64. But let's try and figure, so you can just use calculator to figure out this and confirm if it is indeed 64 and this one to indeed 0. So that's what you are going to get for question 4. Now let's look at question 5, which talks about linear approximation. So linear approximation, we need L of x to be f of a plus f prime of a, x minus a. And I said our x is always a, so this is indeed a. So our L of x is equal to f of 1 plus f prime of 1, x minus 1. This one is unfortunate, we don't have everything, so we just need to go and look for f of 1. So we have the function here, so I can plug it in and have fourth root of 1, which is 1. Now we need f prime. We've gotten f of 1, we need f prime of 1, but for us to get f prime of 1, we need f prime of x first. So f of x is equal to fourth root of x, which is the same as x to the power 1 on fourth. So this is f prime. Use the power rule. We have 1 over 4. Subtract 1, and this is minus 3 over 4. Then we can plug in 1. So f prime of 1 will be 1 over 4. 1 to the power minus 3 over 4. 1 to the power minus 3 over 4 is still 1. So this is going to give us 1 over 4. So now our linear approximation will be 1 plus 1 over 4 x minus 1. So f prime of 1 is this, which is this, and then f of 1 is also here, which is that. So our linear approximation is very simple here, which is L of x, which is equal to 1 plus 1 over 4 x minus 1. Now we want to estimate this. So for us to estimate this, this is what's going to happen. Fourth root of 2 is approximately L of 2, right? Because now when you compare this to this, right, the fourth root of x and the fourth root of 2, you can see that this x is the same as 2, right? So it means that x is 2 here, so we need to plug in 2 here. So this is going to be 1 plus 1 over 4, 2 minus 1, and this is 1 plus 1 over 4, and 1 is the same as 4 over 4. This is going to give us 5 over 4. So that will be our linear approximation there. We are almost done. Now let's look at the antiderivative of these functions. So now let's go through quick. Now f of x should be equal to, now don't forget, if I want to differentiate an exponential function, sorry, if I want to take the entire derivative of an exponential function, this is going to be 2x divided by 2. How did I get this? I maintained the function and then I divided it by taking the derivative of what's on the top. So if you watch the first video, you know how we got this. And then when you differentiate cos, what do you get? Sorry, when you take the entire derivative of cos, what do you get? We get sine, right? So this is going to be minus sine x plus c, which is our constant. So we are going to have e to the power 2x divided by 2 minus sine of x plus c. So very simple from here. Now this one, before we take the entire derivative, we can try to simplify this. So this is x, this is 6x to the power 1, 2 minus, now this here can be written as 2 times 1 over 3x squared, so that we can write this one as 6 to the power 1 over 2 minus 2x to the power minus 3. So everything that we've done here is simplification. Now we are coming to take the entire derivative. So let's use the power rule for this. And this is going to be 6x to the power 1 over 2 plus 1 divided by 1 over 2 plus 1 minus 2. And this is minus 3 plus 1 divided by minus 3 plus 1. Simplify. This is 6x to the power 3 over 2 divided by 3 over 2 minus x to the power minus 2 divided by minus 2. And then if we want to continue simplifying this, let's try and see. But we can leave our final solution here. I can see that this is the same as 4x to the power 3 on 2 plus x plus 1 divided by 2x squared. But if you cannot see this, there is no problem with that. So this is what we need to get. Right. Oh, there is 2 that I didn't bring. There should be 2 in front of this. So even the 2 will cancel out and have something like this here. Then plus my constant. So 4x to the power 3. Is it supposed to be minus or is it supposed to be positive? Let me see. Okay, we added, so 3 over 2 plus 1 over x squared plus c. Yeah. But if you cannot do that, you can just leave it in this form too as well if you cannot simplify. Because what happened here, what happens here to get the 4 was 6 divided by 3 over 2 is the same as 6 times 3 over 2 over 3. Now 3 goes to itself 1, goes here 2. 2 times 2 is 4. So that's what happened there. Find a specific function that meets the following condition. So I think this question was also familiar with what we just did. So now let's go with f of x will be equal to, use the power rule here. What do we get? 4x to the power 4 divided by 4 minus, use the power rule here. What do we get? 6x to the power 3 divided by 3 plus 2x, because there is no function to it, so we multiply it by x, and then we add our constant. Let's add our constant c. So we can simplify this and have f of x is equal to x to the power 4 minus 2x to the power 3 plus 2x plus c. Now this initial condition will help us to find for c. So let's do that. Now when you compare this to this, x is 1, so we are going to have f of 1 to be equal to 1 to the power 4 is 1 minus 1 to the power 3 is 1 times 2 is 2 plus 2 plus c. So I was just doing substitution here. F of 1 is 6 from here. And then when I combine all this, I have 1 plus c. So my c should be 5, which is like 6 minus 1, which is 5. So now my function will be f of x, which is equal to x to the power 4 minus 2x to the power 3 plus 2x plus 5. So what I was doing here was I was writing this function again, but now I changed the c to 5, and I have my function right here with me. So this is the function that when I differentiate, I'll get this. So you can try to differentiate this, and you see that you're going to get exactly what is here. So that's what we need to just get there. Now question 8, then we just finish it with question 9, is we want to use the L'Hopital's rule to see if we can solve this. So now first let's check if it satisfies the L'Hopital's rule. Now e to the power 2, when I plug in infinity, 2 times infinity is infinity, e to the power infinity is infinity. When I plug in infinity here again, I'll get infinity plus constant, which is still infinity. So it means that now we can use the L'Hopital's rule. So now let's use the L'Hopital's rule here, and we are going to have this one to be, so now limit x is approaching infinity. Now let's differentiate this function here. So when I differentiating e to the power x, don't forget this is going to be e to the power 2x times 2. So I maintain the function, and then I differentiate what is on the top, and I used to multiply it. Remember this, right? U prime, when I differentiate this, I have u times u prime. So that's what I'm going to get from there. Now divided by, when I differentiate this constant, it will be 0. But when I want to differentiate this, I have a constant here already. So I'm going to have 4. So let me put the 0 here, plus 4e to the power 2x times 2. Because I need to make sure that I multiply it by taking the derivative of what is on the top. So now let's try and simplify this and see what we are going to get from here. So now this is the same as limit x is approaching infinity, 2e to the power 2x. 0 will just go away. 2 times 4 is 8e to the power 2x. And then this will cancel this. And then 2 cancel itself 1 and cancel here 4. So we are going to have limit x is approaching infinity 1 over 4. Limit of a constant is the constant. So we get 1 over 4 as our final result here. Now let's finish this one very quick. Now this one, I'm going to let it be equal to L. And then I'm going to take the natural log on both sides. So limit x is approaching 0 from the positive. Natural log of 2x plus 1 to the power 1 over x is equal to the natural log of L. Now this natural log here will help us to drop this one behind. So we are going to have this approaching this, which is 1 over x, natural log of x plus 1, and then natural log of this. Now we can write this one as limit x is approaching approaching 0 from the positive side, and then 2x plus 1 divided by x, which is equal to this. Now, before we continue, we need to test if we can use the L'Hopital's rule. So plug in 0 here. This one will be 0. Ln of 1 is 0. So this will be 0 on the top. And indeed, when you plug in 0 on the down, you get 0 too. So now we can now use the L'Hopital's rule. So we are going to use the L'Hopital's rule. So I'm putting the L'Hopital's rule here. Now, let's see what is going to happen here. Now, when I differentiate this, remember, when I differentiate ln of u, let me use different color to write this one here. When I differentiate ln of u, I have 1 over u times u prime. So here is going to give us 1 over 2x plus 1 times 2, because u prime will be just 2. Because when I differentiate this, I get 2. Divided by 1, which is equal to the ln of L. So now what is happening here? Now we can write this one as x is approaching 0 from the positive, and the top will be just 2 divided by 2x plus 1, which is equal to the natural log of L. So now we can test by plugging in 0 to see what we are going to get here. So set x to be equal to 0 and plug it in. We are going to have this 2 divided by 1, which is equal to the natural log of L. And this implies that 2 is equal to the natural log of L, and then e to the power 2 should be equal to L. So this is what we are going to get for our function here. So this is the same as e to the power 2. So this is just step by step, and then just do it. Sometimes you need to do the L'Hopital's rule like 3 or 4 times before you get the actual solution. So this is the last question. Let's go through and then we are done with this. Now, if f prime of 3 is equal to 0 and f prime prime is equal to 2, then at x, f of s is guaranteed to have. So now, anytime we have this one to be 0, so for example, if we have our sign chart and we are picking a value, let me put, where can I put my sign chart? Okay, let me put it here. So if I have, let me say 2 here, or let me say 1 here, and I pick f prime of 3 and I'm getting 0, this one is not telling me anything. It's just 0. So I don't know whether the function is increasing or decreasing. I don't know. So this one is not telling us anything. This one is telling us that we should move to the next one, which is the f prime prime. So now f prime prime here is, now if I have 1 here and I pick, oops, so this one, I should have done it this way. Let me put the 1 here. Good. Instead of putting it there, let me put it that way. So now this one, now f prime prime of 3 is equal to 2, which is positive. Now anytime we have positive, we have what? Concave up. So anytime second derivative is positive, we have concave up. So when you have concave up, then it means that we have what? Minimum. So we have minimum. So it means that what is going to happen here is we are going to have, so here you need to pay attention very well. We are going to have the local minimum. We are going to have local minimum, right? Not absolute. Absolute is when we are using the original function. So you cannot choose local minimum. Good. Now let's look at B. F of x is continuous and f prime is greater than 0. So we definitely need to have sign chart here. So we have interval from -1 to 1. So -1 to 1. In between this interval, f prime is greater than 0. So if f prime is greater than 0 in between that prime, then we're going to have increasing function. And then in between 1 and 4, so I have 1 here already, so I can add 4 to it. And in between 1 and 4, I have f prime less than 0, so this one is going to decrease. And then the question is saying that then at 1, f of x is guaranteed to be what? So at 1, what is happening here? We have this. We have this. So we have local maximum, right? So we can choose our local maximum here. Good. So here the diagrams, the sign chart helps. Now let's look at this one too. If f of x is continuous and f prime prime, okay, is less than 0 in between this. So let's put the sign chart here. If I put 1 here, from -infinity will be here, so 1. And f prime prime is less than 0, meaning that it's negative. And anytime we have negative, we have concave down. Good. So we are done with this. Now, in between 1 and 4, we have the function to be less than 0. So also negative. And this is also concave down again. And then we have from 4 to positive infinity. And that one, the function is greater than 0. So we are going to have this one to be positive, and we are going to have concave up. So now the question is asking us, which of the following is true? F of f of x has um, a point of inflection at 1. This is not true because the sign is not changing. F of x has a inflection point at 4. Yes, this is changing, so we can choose this. Let's see if we have more options. F of x has inflection point both this and this, which is not true. Has no inflection point, which is not true, so it's just this one only. Let's do the last one. Which of the following limits could we apply the L'Hopital's rule? So which one of these can we apply the L'Hopital's rule? So remember, the L'Hopital's rule is either we have 0 over 0 or we have infinity over infinity, plus or minus, plus or minus. So now first let's plug in 2. Plug in 2 here, and what do we get? Let's check. When I plug in 2, I have 4 minus 2 divided by 4 plus 2 minus 6. What do we get here? This is 0 over 0. Okay, let's continue. Plug in infinity here, and this one we can even compare the degrees. Okay, let's plug in infinity here and see what we are going to get from here too. When I plug in infinity here, infinity here is going to be infinity divided by infinity, because infinity cube is infinity. When you subtract infinity, you get infinity. When you add, you get infinity here. And same thing to the denominator too. Now let's look at this one. When I plug in 0, sine 0 is 0, and the denominator too will be 0. So you see that the answer is just going to be this, because we are saying that which one we cannot apply. This is 0 over 0, which is here. Infinity over infinity and 0 over 0. So indeed, it's going to be this. Let's check if it is true. Now, plug in 3 on the top. We get 9 minus 4 divided by 3 on the down. We get 9 minus 6 minus 3. So the top will be minus 4 divided by 0. So this is going to be negative infinity, right? Because we have constant on the top and we have 0. So we don't have this. So it means that we just need to choose this one and we are done. So this is the end of the video. And then, yeah, I'll see if I need to do the discussion review. If not, then all the best in your exams. If yes to, see you in the next video.